Hello and welcome back to the Cracking FAANG YouTube channel. Today we're solving house robber number 2, Leetcode 213. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. This means that the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected that will automatically contact the police if two adjacent houses are broken into on the same night. Given an integer array nums representing the amount of money each house contains, return the maximum amount of money you can rob tonight without alerting the police. So let's look at a basic example, and this is when we have three houses, and this is a very simple case because either we can rob, actually we can't rob the last one, we can't rob 1 and 2 because it's circular, so we couldn't rob them. So we can basically only choose one of the three houses. Obviously we're going to choose 3 because it has the most amount of money. But we don't like those examples because they're too simple. In this case, where we have more than one house, basically we can not rob these two together. So we can either rob these two or these two, right? Because we have to leave a gap of one house. So robbing these two will give us 4, and then robbing these two will give us 3. Obviously 4 is larger, so we're going to do that one. And this question is really basically the same as house robber 1, except with this condition that we cannot rob the first and the last house because it will set off the alarm. So we're going to use the exact same algorithm here, except we only want to consider the array in kind of 2 ways. We can either consider it from the start up until the kind of very last element. We don't want to consider this one because we can't rob them together. Or we want to basically rob from the first index up until the end. So basically we're going to consider 2 separate arrays here. So from basically the start to -1, we want to do that. And then from 1 until the end. So we'll basically just use the house robber algorithm from the first one to check whether or not we can get a better solution. And just as a reminder, what we do is basically we go through all the houses and we're going to keep track of the previous, whoops, you can't see that actually, sorry. We're going to keep track of the previous house value. So previous house, oops, house, and then 2 houses before. So we're going to keep track of those 2 values. And basically whenever we want to make a comparison, we want to check whether or not robbing the previous house is actually better than robbing the current house plus 2 houses before. So if this is the case, if this side is greater, so if the current house plus 2 houses before is greater than the last house we saw, then we want to actually rob the current house plus 2 houses before, and then move on and basically update our kind of our variables here as we go along. And in the end, we'll kind of have our maximum solution stored for us. So that is essentially what we want to do. And you know, it's basically the same code as house robber 1. So let's now actually go into the code editor and type it up. Okay. Let's now code this up. Let's handle some of the base cases that we want to work with. The first one is if there are no houses or houses is somehow none, then we just want to return 0 because there's nothing to rob. So we're going to say if the length of nums is actually equal to 0, and actually I don't think that you can get a null one here, so it's fine. We'll just, if it's 0, then there's nothing to rob. We return 0. If the length of our houses is just 1, then there's only 1 house to rob, so we'll just do that one. So we're going to do if len nums equals to 1, then we're going to return nums of 0. Otherwise, we want to basically check which houses we should rob, and this is going to be the maximum of, remember, we cannot do the first and the last house, so we're going to slice our array to basically not consider the first and the last house, so they won't actually be next to each other, and we can just apply the house robber 1 algorithm exactly to do it, and then we'll just take the maximum of whatever these 2 are. So we're going to say self.rob helper, and we are going to check nums from the start until the one element from the end. And we're going to do, so that basically cuts out the last element to make sure that we don't have that wraparound. And then we're going to do rob helper from nums from the start up until the end. So that this is basically excluding the last element, and this is excluding the first element. Okay, so now all we have to do is define the rob helper function. So rob helper self, and this is going to take in the nums we want to work with. Now remember, we need our variables, so we're going to say the prev house is going to equal to 0, and then we're going to do 2 houses ago, and this is also going to be 0. Now we just need to basically go through the numbers and make the check for what is the best solution here. So we're going to say for num in nums, we're going to say that the best profit here is going to be the maximum of whatever the current num is, so the current house value, plus 2 houses ago, because remember we can't rob 2 houses next to each other, so 2 houses ago, and whatever the previous one is. So either we take the previous house value, or we do the current house and 2 houses ago. Whatever's higher is the best solution. Now we need to update our answers, so we're going to say prev and prev house and 2 houses ago. This is going to equal to best and prev. So prev house is going to be best. So basically the best solution that we have so far is being stored in the prev house, and then 2 houses ago is whatever the current previous is. This should be prev house. So, okay. That is basically it. And then at the end, you simply return whatever is being stored. So the prev house or 2 houses ago. So you're going to return the max here. And there you go. So I think that's it. We can run this. Prev is not defined. Of course it isn't. Prev house. And okay, cool. Submit this and cool, accepted. So just like House Robber 1, relatively straightforward. This is actually the exact same code. I think I just changed some of the variable names from my previous one to make them a little bit more clear, but it's the exact same code. We just have to add this stipulation to avoid the circular nature of the problem. So the time complexity, like House Robber 1, is again big O of n. We just check each element once, and we basically go through the array from left to right, so big O of n. Space complexity, we don't define any extra space here, so all we're going to do is, yeah, it's just constant space because we just have some pointers here. And there you go. So that is how you solve House Robber 2. Basic extension of House Robber 1, nothing really too fancy here. This is the exact same code from the first problem. If you understand that one, then this one is really just like an extra line. Anyway, hopefully you learned something today. We don't usually do DP questions on this channel, but this one is relatively straightforward. Anything that has like a DP array, then I stay away from it quite far. So anyway, hopefully you learned something today. If you did, why not leave a like and a comment? Helps me with the channel, and I will see you in the next one.